Good morning. Myself P. Vanitha, working as a assistant professor. Today we will solve the numerical problem based on statistical analysis of measurements. In the previous class, we studied arithmetic mean, deviation, average deviation, standard deviation, and variance. Now we will apply those formulas to a practical problem involving current measurements taken by different observers. This type of problem helps us to understand how random errors are analyzed using statistics. Now let us see why we use statistical analysis in measurements. Statistical analysis helps us to determine the uncertainty of the final test result in an analytical way. That means instead of guessing how accurate our result is, we use mathematical methods to find how reliable the measurement is. For this purpose, we mainly use parameters like arithmetic mean, median, and average deviation. These quantities helps us understand how the measured values are distributed and how close they are to the true value. Now let us look at the arithmetic mean. The arithmetic mean is mathematically given by x bar equal to x1 plus x2 plus and so on up to xn divided by n. Here x1, x2 up to xn are the individual measured values and n is the total number of readings. This arithmetic mean represents the average values of all the readings. If the number of readings is very large, then this mean value will be very close to the true value of the quantity being measured. That's why in practice we take many readings and use the average as the final measured value. So arithmetic mean is a very important tool in statistical analysis because it reduces the effect of random errors and gives a better estimate of the true value. The most probable value of measured quantity is the arithmetic mean of all the readings taken. It is calculated by adding all the readings and divided by the total number of readings. Here, x bar represents the arithmetic meaning, x1, x2, x3, xn are the measured values, and n is the number of readings. This average value is taken as the final result because it is closer to the true value and reduces random error. Deviation is the difference between an observed reading and the arithmetic mean of all readings. It is calculated as D equals uh, x minus x bar, where x is the observed value and x bar is the mean value. So for each reading, we find its deviation d1, d2, d3, and so on. When we add all the deviations, their sum becomes 0. This shows the some readings are above the mean and some are below the mean and they balance each other. Deviation helps us understand how far each reading is from the average value. Standard deviation is the measure of how much the readings vary from the mean value. It is defined as the square root of the sum of the squares of deviations divided by the number of readings. For a large number of observations, that is more than 20 readings, standard deviation is given by sigma equal to square root of sigma d square divided by n. For a small number of observations, that is less than 20 readings. Standard deviation is given by S equal to square root of sigma d square divided by the n minus 1. Here d represents deviations from the mean and n is the total number of readings. Smaller standard deviation means readings are closely grouped and the measurement is more precise. Now let us see variance. Variance is defined as the square of the standard deviation. It represents how widely the readings are spread from the mean value. For a large number of observations, variance is given by sigma square equal to sum of d square divided by z. For a small number of observations, variance is given by s square equal to sum of d square divided by n minus 1. Next, average deviation, also called the mean deviation. It is given as the sum of the absolute values of deviations divided by the number of readings. Mathematically, average deviation is given by AD equals sigma of absolute value of xi minus x bar divided by n. Both variance and average deviation helps us to understand the spread of measured values and the reliability of the measurement. Here, a set of independent current measurements are given. Six observed measured the same current and recorded the following values: 12.8 amps, 12.2 amps, 12.5 amps, 13.1 amps, 12.9 amps, and 12.4 amps. We are asked to calculate arithmetic mean and median, deviation, average deviation, standard deviation, variance. So this is a complete statistical analysis problem. First, we will write the given values and the number of observations. Number of observation n is equal to 6. First, let us calculate the arithmetic mean. Arithmetic mean is obtained by adding all readings and dividing by the number of readings. So we add 12 plus 8 plus 12.2 plus 12.5 plus 13.1 plus 12.9 plus 12.4. The total is 75.9. Now divide by 6. So mean value is 12.65 amperes. Next we find the median. For that, we arrange the data in ascending order. Since the number of readings is even, median is the average of the middle two values, that is 12.5 and 12.8. So median equals 12.65 amperes. We observe that mean and median are equal. It shows the readings are symmetrically distributed. Next, we calculate deviations. Deviations means the difference between each reading and the mean value. So deviation is calculated as d equal to x minus x bar. For 12.8, deviation is 12.8 minus 12.65, which is 0.15. For 12.2, deviation is 12.2 minus 12.65, which is minus 0.45. For 12.5, deviation is minus 0.15. For 13.1, deviation is 0.45. For 12.9, deviation is 0.25. For 12.4, deviation is minus 0.25. We also calculate absolute deviation and square of deviation. Absolute deviation is taken to avoid cancellation of positive and negative values when we find the sum of absolute deviations and sum of squared deviations. Here, the sum of absolute deviations is 1.70, sum of squared deviations is 0.575. Average deviation is calculated by dividing the sum of absolute deviations by the number of observations. So average deviation. So average deviation equals 1.70 divided by 6. This gives 0.283 amperes. This value tells us the amount by which the readings differ from the mean value. Smaller average deviation means the readings are closer to each other. So finally, summarize the result. Mean is 12.65 amperes, median is 1.65 amperes, average deviation is 0.283 amperes, standard deviation is 0.309 amperes, and variance is 0.0958 ampere square. These values tell us that the measurements are closely grouped and hence the measurement is reliable. To conclude, this problem shows how statistical tools are used to analyze random errors in measurements. By calculating mean, deviation, standard deviation, and variance, we can judge the reliability of measured data. This method is very useful in electrical and electronic measurements. Thank you.